Alright, let's try this again. So I started making this video and then my whole computer just shut down. So I have some of the stuff already written, so we're going to go through that. Today we're going to work on multiplying mixed numbers by mixed numbers. We worked on multiplying fractions by whole numbers and fractions by fractions. So now we're going to do mixed numbers by fractions and mixed numbers by mixed numbers. So the first thing that we need to review is just to turn a mixed number into an improper fraction and vice versa. So here's my mixed number, and I'm always going to start at my denominator and work in a clockwise fashion. So if I start at my denominator, you're going to multiply your denominator by your whole number and add your numerator. So 5 times 8 is 40, plus 4 is 44. That is my numerator now. And then my denominator is going to stay the same. So again, I have 5 times 8 is 40, plus 4 is 44. Denominator stays the same, which is 5. I wrote the steps here. If you do not remember the steps, or if it's hard for you to remember, please write those down. Pause the video if you need to. And then we are going to move on to changing an improper fraction to a mixed number. So I have 16 sevenths. The first thing you're going to do is just divide. So this is essentially 16 divided by 7. Your remainder is going to be your new numerator. Your denominator is going to stay the same, but what is my whole number? My whole number is how many whole times 7 can fit into 16. Well, 7 can only go into 16 2 whole times. Okay, so that's my whole number because I can only get to 14. My denominator is going to stay the same, and sometimes I like to think of it as working backwards. So I like to think of, well, I need to get to a mixed number, and I know the algorithm for getting to a mixed number, or an improper fraction I should say, is to multiply and add. So if I look over here, if I multiply 7 times 2, I get 14, and then what do I need to add here to get to 16? Well, right now I'm at 14, so I would need to add 2 more. So 2 and 2 sevenths. You can also just do the division. If I did 16 divided by 7, I would get 2 remainder 2. The remainder is going to be your new numerator, and your denominator stays the same. When we multiply fractions, unlike adding and subtracting fractions, we do not need a common denominator. Okay, so that's different than adding and subtracting. When we add and subtract fractions, we do need a common denominator. I can show you this with a model. So with the model, we have 1/2 times 3/4. I first drew one whole rectangle. So here's the perimeter of my rectangle. I split it into half, so that represents the first fraction. Then I'm going to go the opposite direction, so horizontally, and split it up into fourths. So 1, 2, 3 lines makes 4 parts. And then I'm going to shade in the fractional pieces. So I need to shade in 1/2 of my rectangle, so that's this squiggly line, that's 1/2 of my rectangle. And then 3/4 would be 3 of these horizontal rectangles. And then you can see here where they overlap. I have 1, 2, 3 squares where they overlap out of 8. So that's represented with 3/8. The difference down here, though, is now that I have a mixed number, I would need to have one whole rectangle filled in, 1 and 1/2. And basically, when it comes down to it, when we do this kind of math, we don't really take the time to draw all these models. It's just visually how you can see how we multiply fractions. But I'm going to go ahead instead and change this to an improper fraction. So again, we're going to multiply and add. 2 times 1 is 2, plus 1 is 3. Denominator stays the same. So now I have 3/2 times 3/4, and I get 9/8. And I need to put that back into a mixed number. So 8 can go into 9 one whole time. I know my denominator is going to stay the same, so again, I need to multiply and add something to get to 9. So right now, if I multiply this, I get to 8. So I need to add 1 more to get to 9. Okay. So again, it says first we must rewrite the mixed numbers as improper fractions. So I'm going to do 5 times 2, which is 10, plus 1 is 11. So 11 fifths times 1/3. And then hopefully we remember how to multiply from the other day. We get 11 fifteenths. And that is simplified. I cannot do anything more to that fraction. Always start at your denominator. 7 times 1 is 7, plus 4 is 11. Denominator stays the same, times 1/2. I can't simplify anything here before I multiply. So when I multiply, I get 11, and then 7 times 2 is 14. So 11 fourteenths. Right, I'll turn the page. Alright, change this into an improper fraction. So 12 plus 5 is 17 sixths times 2/3. Now again, I always want to think if I can simplify something first. And it looks like, let me focus here, the 2 and the 6 are both even. So I know I can divide this by 2 and this by 2. When I divide 2 by 2, I get 1. And when I divide 6 by 2, I get 3. So when I multiply across, I get 17 ninths. I'm having a really hard time focusing. You need to turn that into a mixed number, so 9 can go into 17 once. And if I multiply here, I get 9, so I need to add 8 more to get 17. So 1 and 8 ninths. Okay, number 4, I'm going to change this into an improper fraction. So 4 plus 3 is 7 fourths times 4 sevenths. Now again, if I have something in my numerator that is the same as something in my denominator, they just cancel out to 1. Why is that the case? Well, multiplying is commutative, which means I can switch the order. So if I switch the order, that means I can write it like this. 7 divided by 7 times 4 divided by 4, which is essentially 1 times 1 is 1. So whenever I see a problem like this, I just cross these off. It's just always 1 times 1, and you're going to get 1. Okay, number 5, I have 6 times 3, which is 18. 18 plus 1 is 19 sixths times 4 fifths. Now this one especially I'd like to simplify first, because if I don't, I'm going to end up with large numbers, and then sometimes it's harder for me to simplify large numbers because I can't find a common factor. So I'm going to simplify the 4 and the 6. They're both even, so I know 2 can go into both of them. 2 can go into 4 twice, and it can go into 6 3 times. 19 times 2 is 38, and 3 times 5 is 15. We're going to put this into a mixed number. 15 can go into 38 twice, because that gets me to 30. So I'm going to add 8 more to get to 38. So 2 and 8 fifteenths. So what I want you to do right now is do 6, 7, and 8. You're going to pause the video and unpause the video to see if you have the same answers that I do. If you don't have the same answers, figure out where you made your mistake. So again, pause the video right now and do 6, 7, and 8. Oops. Okay, so hopefully for 6 you got 5/16, 7, you got 4 and 8/9, and 8, you have 8. Okay, we're going to skip number 9. Again, modeling is nice if you're confused, but hopefully you all can see the pattern here where we just changed it to an improper and multiply. If you'd like to go over the modeling, we can with number 9. So then for homework or for the rest of the time, you are going to work on this. You have a couple problems to do. So 10 problems to do. When you're done with that, there is something else. So let me know when you're done.